over here you can break it, or you can what? Let's do one thing. The highest power of x is what? X cube. Okay, let's make it plus over here. So in order to make plus over here, I will take minus common. Now if I take minus common, for timing, let's take minus over here. It will be x cube. Okay, here minus plus x square. Here plus x. Let's see 1. Okay, let's see whether it is correct or not. Minus x cube minus plus x square plus minus x minus plus. Okay, now this is perfect. Now the highest power of x is what? X cube. I am making plus over here. Okay, now x cube here plus x square minus x minus plus. Okay, now let's send this minus outside. Here minus integral of dx upon x cube minus x square plus x minus 1. Okay, now let's consider this. Okay, let's consider this. Let's try to factorize it. Now let's consider x cube minus x plus x minus 1. Now if I take x square, x common, okay, then x square minus 1 plus 1 x minus 1. Is it correct? Here if I x square, okay, sorry, this is square. Okay, check it. Now here x into x is x cube. Here what I am taking is I will take what? X square common. X cube, here x square, here plus x minus 1. Okay, therefore this can be written as x square plus 1 into x minus 1. If it is x square minus 1, you can express again a minus b, a square minus b square, that's a minus b into a plus b. Okay, now this can be written as this. Okay, therefore this minus is outside, remember minus is outside, integral dx upon x minus 1 x square plus 1. Okay, now let's consider this we have to do by partial fraction. Okay, now this we cannot break more. Okay, if we could have break more, then it can be more linear. Okay, now let's by partial fraction, let's consider this minus. Okay, we'll consider in later on. This minus we'll make it later. Okay, now 1 upon x minus 1 into x square plus 1 can be written as a upon x minus 1 plus here this, since it is linear, I have chosen only one constant over here. Since it is x square, I need to choose two constant associating with variable. Okay, here bx plus c upon x square plus 1. Okay, now our aim is to find the values of a, b, c, these arbitrary constants. Okay, is implies multiplying these. Okay, multiplying these on both sides, we have on the left hand side we have 1 equals to a, this x minus 1 and this x minus 1 will get cancelled. We'll have x square plus 1 plus bx plus c, x square plus 1 x square plus 1 will get cancelled. We'll have x minus 1. Now our aim is, remember our aim is to find a, b, c. Okay, now if I substitute x equals to 1 over here, this term will get 0 and then I will get the values of a. Okay, now let's put x equals to 1 in this equation. Okay, in this equation, therefore on the left hand side constant is there, so no effect. Here a into, instead of x I am putting 1 over here. 1 square is 1, 1 plus 1 is 2. Okay, but here 1 minus 1 is 0, 0 into anything is 0, we don't have to write. Okay, therefore from here a equals to 1 by 2. Okay, we have now a equals to 1 by 2. We want to find b and c. Okay, in order to find b and c, what we can do is we can compare various parts of x in this equation. Okay, in this equation what we have is what, let's expand once more so that it will be easy one. It will be easy. Is equals to 1 equals to a into x square plus a. I'm expanding this. Okay, here b into x square minus bx plus c into x is cx, here minus c. Okay, this term is over here and this term is over here. Okay, here b into x is what, bx square, bx into minus 1 is minus bx, c into x is cx plus c into minus 1 is minus c over here. Okay, now let's compare the coefficient of what, x square. Okay, now coefficient of x square on both sides. Okay, now on the left hand side, coefficient of x square is what, we don't have anything over here. Okay, anything is here, therefore 0 equals to, now coefficient of, on the right hand side, coefficient of x is what, a, here b. Okay, here a plus b, 0 equals to a plus b. We have one equation. Okay, remember a is half. Okay, this implies a equals to minus b, or you can say b equals to, therefore since a is what, half, b will be minus half. Okay, or you can say b is minus a. Okay, therefore we have b. Now let's compare constant terms over here. Okay, if I compare constant term, or you can say if you compare coefficient of x is what, we have b and c. Okay, let's see, let's compare coefficient of x on both sides. Coefficient of x is here, we don't have anything over here. Coefficient of x is over here, here minus b. Okay, we have minus b and plus c. Is implies b equals to what, c, means therefore c also minus half. Okay, so now we have a, b, c and substitute over here. Okay, substitute over here, but this integral is what, we have minus over here. Okay, minus, therefore this integral become, integration of this become what is, a is half, I will write over here, a is half, we have a is half, b is what, minus half, here minus half, as well as c is also minus half. Okay, then we need to integrate this. Okay, now integral of this, here dx, here dx. Okay, now integration of this is what, differentiation of this you are getting, therefore that is half of log of x minus 1. Okay, now here, okay, here I can take minus half common over here. If I take minus half common, integral here x, or you can say x plus 1 upon x square plus 1. Look here, if you send minus half over here, minus x by 2, here minus half. Okay, into dx. Okay, be careful, here we have minus over here, so outside you can keep minus. Okay, now this part integration is over, so I will write here is equals to minus of half log of x minus 1, you can write mod or in first bracket minus half. Okay, now I can separate this upon this and this upon this. Okay, I can separate this upon this and this upon this. So now again I will put bracket over here, integral x upon x square plus 1 dx, this is plus over here, plus integral 1 upon x square plus 1 dx, and now and his second bracket over here, here minus half log of x minus 1 minus half. Now let's put first bracket over here, Now differentiation of denominator is what? Twice x plus 0. Okay, so we need 2. Okay, so I need to have twice over here, but this 2 is extra, so I need to put over here. Okay, now therefore this term, okay, whole this become what? Whole this become log of, so half will be there, half log of x square plus 1. This part integration is over, plus. Now this we have integral of 1 upon x square plus a square dx is 1 by a tan inverse x by a plus constant. Okay, applying this formula here, 1 by a means 1 by 1 is 1, tan inverse x by a means x. Okay, and this bracket. Therefore if I send minus inside, okay, if I send minus inside, will be what? Minus half log of x minus 1 minus minus plus. Here will be, again I am sending here, here what? 2. Okay, 2 to the 4 log of x square plus 1. Okay, here minus will be here. Okay, here minus tan inverse of x plus c. Okay, this is the required